already covered what do you mean by multi-threading. So now you already know that, okay, what is multi-threading, why multi-threading is very important, because we want concurrent execution of your programs, right? And why what are the applications of the multi-threading? You already know about that. Whenever we want to work, or whenever we want to execute multiple queries on your servers, like in JSP, we generally use the concept of multi-threading. And if you want to take some more examples, suppose you are designing some game, or you are creating some cartoons, right? So in that scenario, you will have what, same background, right? But you are having different characters which are basically playing different roles. So over there, what you are doing, you are using the concept of multi-threading, right? So this is how basically we can use multi-threading, and the main idea behind multi-threading is because we want to achieve the maximum utilization of CPU, right? And we want to and we can basically run all these threads parallelly. Okay, so in reality we are not running it, but somehow there is a very small difference whenever we are executing these threads. So somehow it seems like, okay, we are executing all your threads parallelly, right? Like that. So all these things we have covered so far. We know how to create threads. So I don't think so. So in today's lab also, so those who are going to, in your first lab, you have to solve the problems related to your threads. Okay. So now you already have an idea that how to create threads, right? So this is what you have to do in your this week lab, right? So what is the role of thread scheduler? Because every time your output will you will get different outputs if you are working on different what we call it as your if you are executing different threads, multiple threads. So you can see what is the meaning of T start. So this is by default method that is already there, and you will find out that there are several other methods, right, that are constructors, as well as there are several other methods too, right? So out of which in today's lecture we are going, so we have already discussed about get and set name method. I'm not again going to revise it, but still if anyone is having any doubt with respect to anything, they can directly ask, right? Now, so we have already discussed about thread priority 2. Now in today's lecture, we are going to start with these three functions. So in this week lab, you have to basically solve and you have to use the functionalities of these things, okay, these methods. So now the question is, right now what you are doing, for you are creating multiple threads like T1, T2, T3 and T4. Now how we are basically executing, what is the order of execution? We cannot comment on that. Why we cannot comment on that? Because it's all totally being managed by whom? Our scheduler. Okay, our scheduler is managing like in which order we are going to basically execute our threads. Okay, so we cannot say all these things, but using these methods, what we are achieving, we are preventing the thread executions. So using why, if you want to prevent some thread, okay, for your execution, then you have to use these three methods, right? So let's check it out how we can prevent these thread execution using these methods. So let's take our first method, and the name of this method is yield method, right? What is the meaning of what this method do? Let's go through first theoretical definition, then I will tell you what is the meaning of yield method. Now, so in the yield method is a static method of a thread, and it can stop current executing thread and will give a chance to other waiting thread of same priority. So what I have told you that we have, let's assume we have a single processor. Means single processor means we can execute only one process, and you can call it as, suppose we can execute only one thread at a time. Then what will happen? Our first thread, let's assume, will come and it start executing. Then at that time, suppose if we have thread T2, thread T3, then what these two threads are doing? They are doing nothing, but they are waiting. Waiting for what? Waiting for their turn, right? And who will provide this thing, that which is, this one will execute, which process means which thread we are will execute at that moment of time, our thread scheduler, right? Now let's assume I want that particular scenario where I want that, okay, I want that, okay, if let's assume there might be some scenario, okay, if I am executing some thread, let's assume I am executing thread T1, and let's assume I got some other threads too, means I'm having some other threads whose, basically you can call it as like this, whose priority, so you already know that we have already discussed about priority, and you know that if their priorities are equal or greater than that, right? So let's assume if their priority are basically greater than, so we have 4 threads and one priority is less, that is 3. Now let's assume if we are executing this particular thing, and I want to basically perform some operation in such a way that I want that if there is a thread, okay, if we are having some thread, those who are waiting, and if their priority is equal to and greater than that particular thread, then what it will do, then it will basically stop executing this particular thread. So here we are explicitly telling our scheduler that, hey scheduler, I don't want to execute, right? This T1 will say, hey scheduler, I don't want to execute, and just check it out, if is there any threads who are basically waiting and are having the same priority. Then our scheduler will say, yes, we are having 2 threads for over there. Then he will say, then stop me. Then thread will stop automatically our thread T1 execution, and it will start executing your T2 thread, right? Like this. But let's take one scenario where you are having only these 2 threads, but this thread is having a less priority, okay? Having a less priority than T1 thread. Then in that scenario, whether this particular method will work or not, the answer will be no. In that particular case, the functionality of build will not work. Why? Because it will work only for those threads whose priority are basically greater than. Yes. Okay. So whose priority is basically greater than that. So the advantage of yield method is to get a chance to execute other waiting threads. So if our current thread takes more time, so suppose when we basically go for it, suppose let's assume it is taking a lot of time to execute. Let's assume, okay, so what will happen, and suppose scheduler is doing nothing in that moment of time, so we will tell our scheduler, hey scheduler, I don't want to execute, I just want to find out whether is there any other threads whose priority is greater than or equal to me. Then if scheduler will find out those waiting threads, then automatically it will stop its execution, okay, and automatically it will execute and allocate processes to your other threads. Okay, so this is basically the syntax, how you can basically use this particular method. So in which thread you want to use, so for that particular thread, you inside your run method, what you are going to do, you just try to write it down this particular thing, right, like this. So let's take this example. So in this example, what we are doing is we have created a thread class, okay, which is inheriting our main inbuilt thread class. And inside our public void run, we have this particular thing, right? Now after that, we have public static void main. And in public static void main, what we are doing, we are creating this particular object of thread, and we are starting this particular thing. So I will tell you the start execution. Initially, we have only one thread, that is what my main thread. Okay, at this moment of time. So who will provide this thread? Our JVM. Now after this, we are creating an object of thread. So somebody will ask you, how many threads are there till this statement? So remember, your answer will be only one. Okay, when your system will have 2 threads, whenever you will invoke this particular method, that is thread dot start. Now you will have how many methods? 2 methods, 2 threads, sorry. First one is main thread, and second one is your this thread. Now you keeps on executing, and you already know. If I will ask you that what will be the, if I'm not using suppose this yield, okay, if I will ask you, can you tell me what will be the output of this particular thing, then you will say, sir, we cannot comment on that. Then I will ask why you cannot comment on that. Then you will say that, sir, it depends upon your the scheduler, and every time when we will keeps on executing and executing, every time we will get different output. So we cannot comment on that the exact output right now. Now using yield method, what we are doing, see what will happen. Now after that, whenever, let's assume whenever our thread, this basically thread object, now this thread will get a chance, then automatically it will execute this run method. You already know about that. Now after that, it will start executing this loop, and after inside this loop you will find what you will find. You will find this statement, right? Yield statement. So what this statement will do, after executing this statement, it will interrupt this particular thread and it will directly execute your main method, right? It will execute your main method and you will display this particular message. And let's assume again in future also you will get again this particular method. So every time it is basically yielding this particular thing. So if you will execute this particular program, then every time, remember, every time you will get the same output. You will not get a different output for this particular code. I'm not saying that whenever you are using yield function, no, for this particular program only. Now the question that comes into your mind is, sir, why we are getting main every time? Can you print thread 0 anytime? Is there any chance that you can print a thread 0? So let's check it out. So if whenever you are going here, so every time it is yielding. Yielding means it will go and it will check whether is there any thread which is waiting and having the same priority. So yes, as I told you that whenever we are getting some priority, so by default we got the priority as 5. So both your threads are having the same priority. So that is the reason in both the case you will always get the same output. And when this will start executing, this statement will start executing when you don't have any other thread. And when you don't have any other thread, when our main thread will execute all its statement, right? So now once your this entire thread, our main thread will execute all its statement, then automatically this thread will invoke and it will basically check it out whether we have any threads available. Then it will find out. The scheduler will say, no, we don't have any other thread which is having like equal to or greater than your priority. Then it will say, okay, no issue, then I will execute. So that is why you are getting this particular output. If anyone is having any doubt, please feel free to ask, right? Like this. Now there is a one more method through which basically you can basically terminate your existing method. Now let's assume you are having T1, T2, T3 and T4 method, right? So let's assume here you are developing some application, and using that application, suppose this thread is dependent on this thread. This thread means once it will execute this thread, then only you want that it should execute your this particular thread. So in that particular scenario, you have to use the concept of, or you have to use the method known as your join method. So in join method, what you do, the join method waits for a thread to die. Means it will say, okay, keeps on waiting. So let's take this example, okay? I will tell you what this figure will tell us. Let's assume we are having two threads, this thread and this thread, right? Now let's assume you already know that we don't know the order, okay? And there are many statement S1, S2, S3 statements. Similarly, we have S1, S2, S3, S4, S5 statement. So suppose how our scheduler will execute. First, it will execute as, suppose make it as 21, 31, 41, 51. Suppose our scheduler will execute like S1, right? And then S2, then S11. So it can be any order, right? Then S3, then S21, right? 1. See now after this statement, what will happen? In this statement, what you have written is that you have written print a dot join. What is the meaning of print a dot join? Remember that print a is the name of this thread. Now it means that you are telling your scheduler, okay, you are telling your scheduler, hey scheduler, please wake me up only when this particular thread will get complete its entire means execution, right? Then what will happen? It will wait. When it will wait? Till our this entire thread print2 will get executed, right? Once it will execute, once our PA, this particular thread get finished, then again it will start participating in that particular task. Okay. Otherwise, it will keeps on waiting and waiting. So see, if you want to create some threads, okay, and if you want to create some sort of, you can say that the relationship among these threads, that okay, if you are basically executing this particular thread, then we are able to basically execute that particular thread only. Then in that scenario, it is mandatory for you to join this particular statement that is known as your join method, right? Like this. So let's take in this example. So what I have done, so as I told you, initially will have main thread. Now after this, what we are doing, we are creating an object of this thread. So till now we don't have any other thread, right? So after that, what we are doing, we are writing thread1 dot start. So now how many thread I am having? I am having thread1 and I am having main thread. So you already know that now it will our scheduler will keeps on executing like randomly, okay, like the way basically it will execute. So basically it will execute this statement for this particular thread, and for main method what it will do, it will execute this statement. And what this statement is telling us, this statement is telling our main method, remember, it is not telling our this thread, it is telling where the statement where you are writing now, it will tell to that particular method, okay. So it will tell our main method is telling, hey scheduler, please put me in the waiting state till our this particular thread one gets completed, means executed successfully, completely you can call it as, right? So it will, what it will do, it will wait. Now it will wait and our thread one will execute it, the entire thing. Once our thread one will execute the entire thing, then what we will do, it we will terminate, we will remove it. Now again we will have what, only one thread, and now it will check it out. Now the scheduler will say, hey main, now we don't have any other thread, now you can continue your execution. Now once again a main will start executing and it will again execute this statement. Now here it got again what, one more thread that is named as thread2, right? Right. Now after that it keeps on executing concurrently, but once our main method get executed, it's the next statement, again we are getting this statement and we are getting the, it will say, hey wait me up till when, whenever it keeps on it will execute thread number 2. So that is why if you will see now, if you will check it out, the output of this particular code, then you will find out, see, we are executing our first thread, then we are executing second thread, we are executing third thread. So it means we are not executing our thread concurrently. So every time whenever you are going to execute this particular code now, you will get only this output, right? Remember this thing. So using join method, basically what we are doing, we are terminating or putting our current executing thread into waiting state. Okay. So first we have covered what, our this your yield method. Yield method will do what? It will just terminate. Okay. But it will but in yield method again you can come back. Okay. After some time. But here in join method you will come back only if, whenever you are going to complete that particular thread, right? Now the last method which through which basically we can perform this interruption is your sleep method. And using sleep method, what we will do, we will use the sleep method for a specified amount of time, right? So suppose if you want to put your thread Okay, suppose I am working in T1 thread, we have T2 thread and T3 thread. Suppose I am executing T1 thread, and suppose if whenever I am going to execute this sleep method, na, then what will happen? Automatically for that we have to enter some duration. So for that duration, what will happen? T1 will go into the sleeping state. So in that moment of time, T2 and T3 can start executing. So T1 will not participate, okay, at that moment of time. Once that particular sleep is over, then again it will keeps on participating, okay, like this. And remember one thing is that whenever we are using the sleep method now, so we always get this your interrupted exception. Okay, we always get this interrupted exception. So remember, whenever you are using this particular method, every time you have to use the try and catch block or either use the functionality of throws. Okay, keyword, right? Either use try and catch block, either handle it, or either use the your throws, right? Like this. So let's take the example of this particular thing. So here I haven't created multiple thread, but I just want to tell you what will happen if I'm going to execute thread.sleep. So what will happen? I will get the output 0. Then it will take 1000 millisecond, right? It means it will take 1 second, and after 1 second, it will come back again because we don't have any other thread. So again, it will execute this statement and we will get 1. Then it will go here, then it will wait for 1 second, and then we will get 2. So once you will execute this program, so at the same time you will not get 0 1 2 3 4, you will get 0, then it will wait for 1 second, then you will get 1, then you will get wait for 1 second, like this, 4 5 3 4 5, like that, 3 4, right? So this is the functionality of what we call it as your sleep method. So you have to use these 3 methods in your this week lab problems. Okay. Now I think if I will explain now this thread states, now I'm 100% sure. Yes, anybody is having any question, please. Otherwise, you can write. Yeah. Okay. So in this
Why we
scenario,
have to put that sleep method in a try block means why can't we use that normally?
okay. See what happened now. Actually, what they have done is whenever the inbuilt functionality of if you will find see now the inbuilt functionality of sleep block. So what if let's assume if you will put a very large long maybe means the amount of time which you are basically entering now is like 10000000000 so much, then what will happen? So our compiler will say everything is fine. Suppose if it is not, if we are not getting any exception, then what will happen? Our compiler will say, okay, everything is fine. But in reality, they have find out that okay, we are not. What will happen? Because we might get these such kind of errors for this particular scenario. Okay. So what they have done, they have it is mandatory because otherwise. So your question is why we are putting try and catch block, because in your lab, in your basically what we call it as your when we are discussing about exception handling, right? So in exception handling, what I have told you, there are 2 types of errors categories: checked exception and your unchecked exception, right? So whenever you are going to write this particular, whenever you are going to compile this code now, then what will happen in this statement now, our compiler will say, okay, you might get an exception. See, whenever I have given you an example related to file now, even though we are not getting any exception in reality, but what our compiler will say, compiler will say it is mandatory for you to either handle it or either throw this particular exception, right? So for this particular case, what we have to do, we have to handle this exception. So either you can use try and catch block, okay? Either you can use try and catch block for that particular scenario, or either you can use throws keyword whenever you are working in multi-threading. Okay, so always try to consider this particular scenario. Now,
Excuse me, sir.
yes,
Sir, please explain the second method after yield.
this join method.
Yes, sir.
Okay. See what join method is telling you now. Suppose you have, let's take this particular example. Okay, or it's better to explain this particular. See, we have a thread T1, we have thread T2. statement 1, statement 2, statement 3, and after that we have written T2 dot join, and we have statement 1, statement 2, statement 3, statement 4, statement 5, statement 6. We have statement 4. Let's assume there might be some scenario that this statement in a statement 4 of your thread 1, statement 4 of your thread 1 is dependent on your entire thread execution of T2. Let's assume this particular scenario. अगर आपका ये जो statement 4 है of thread 1, ये पूरा इसका जो आउटकम है वो बेसिकली किस पे डिपेंडेंट है, इस thread 2 के execution में. Then in that scenario what we have to do after this particular statement in S3, what we will do, we will directly write it down T2 dot join. So once we will write na T2 dot join, then what will happen, हम ये वाली जो statement है, that statement, your statement 4 of your T1, we will never execute this particular statement till whenever this entire T2 thread gets executed, right? So using this join method, what we are doing, if we are having some dependent thing, okay, some dependent threads. So if you want that, okay, if you are executing this particular thread, then only execute this particular thread. Then in that particular scenario, always try to use this particular method that is known as your join method. Right? Got the answer? Or still having any doubt, you can ask if you have any doubt.
Yes, sir, clear.
Got it? Huh? Yeah. Right, like this. So using this basically in a thread state, now you will understand what I mean to say. See, हम क्या कर रहे थे, whenever we are using start statement, then what will happen, we will go back into our ready state, right? जब भी हम क्या कर रहे हैं, whenever we are writing start, then what will happen, I have told you now, we are able to create our thread. So right now we have two thread, our thread 1 and we have a main method, right? We have two threads. So similarly यहाँ पर क्या होता है, whenever you are going to write, so now you are at ready state. Now when you will go back to run state, everything is dependent on our scheduler, right? So suppose let's assume scheduler will given a chance like you can run your statement. So our thread will go and start executing all the statement inside that run method, okay, whatever the statement are there. Now if you have yield method, remember, if you have yield method, then what will happen, automatically it will again go back to your ready state. अब वो फिर से रेडी स्टेट में चले जाएगा and it will wait for our scheduler, okay, then when scheduler will give the chance or not, something like that. Now in the case of your sleep method, what will happen, suppose if you have written 500,000, okay, so it will wait for that much amount of time, and again after that, after completing that this entire sleep, again it will get back into your ready. So remember, it will it will never go directly to your running state. It will again go back and it will say to our scheduler, hey scheduler, now I am again available, like that. Now for your join method, what will happen? Whenever you are running some statement and in that particular thread, there is a statement named as join, then what it will do, it will go in this particular block. And in this block, what you are doing, it will basically wait. Okay, it will wait for your target to finish. Like suppose it is waiting, our T1 thread is waiting for T2 to complete. So what statement will be there? There will be a statement like this, T2 dot join. Okay, so it will wait. Once T2 gets completed, then what will happen? Again, it will go back and head back to your running state. And once your entire thread is complete, then it will go back into your finished state, right? So this is what we have learned so far. Now after going through this, and this is the last topic of our multi-threading, okay, and this topic is your synchronization, because one question that comes into your mind is synchronization. So first of all, you should know what is the meaning of synchronization, right? Now let's take one example of your railway system, railway management system. In railway management system, at a time, how many users are accessing? Suppose I want to go from Delhi to, suppose I want to go to, suppose anywhere, okay, suppose Kolkata. Okay, now suppose I want to go these four user 1, user 2, user 3, user 4, user 5. 5 user wants to book a ticket at the same time from Delhi to Kolkata. And suppose, let's assume only one ticket is remaining. How many tickets are remaining? Only one ticket. Then what will happen? Whether all the users will get the ticket or only one user? You already know the answer. Only one user will get the ticket. It means we are running 5 users, and you can now map it with your threads. Let's assume 5 threads are executing and they are basically accessing some or updating some data, right? And let's assume what will happen. All 5 will update the data. Then what will happen? You have one ticket. You have only one ticket remaining and 5 tickets you have booked. So is it possible? No, it is not possible. And that condition and that situation is known as your inconsistency. Okay, so in order to avoid inconsistency means whatever the number of tickets that are already available before booking and after booking, how many tickets are booked? One. So it means both in LHS and RHS we are getting 1 and 1. It's not like that you have only one ticket left and you are able to 5 users, all 5 users able to book five basically seats. So is it possible? No, it is not possible. So same situations might occur because you already know all these threads are executing what? They are executing their code parallelly, right? Suppose if you are not using the concept of synchronization, and if all these are threads, then what will happen? All of them will able to basically what? All of them will able to basically book their tickets, right? And that will lead us to inconsistency. So that is why then multi-threaded programs may often come to a situation where multiple threads try to access the same resources, right? Remember, this is very important. Same resources, like for our current scenario, for our current example, our seed is our resource, right? That particular resource. And finally produce erroneous and unforeseen result. So if you are not using the concept of synchronization, then what will happen? All 5 will able to basically book that particular seat. And is it possible in real world? You already know that no sir, it's not possible. So you already know that because it might be possible, they might basically share some your what we call it as some resources, right? So how to manage it, how to perform that we will not get any inconsistency whenever we are using the concept of your synchronize, whenever we are using the concept of multi-threading, then there is a concept known as your synchronization, right? So it needs to make sure by some synchronization method that only one thread can access the resource at a given point of time. Then what I mean to say is that how to sort out this particular problem, you already know. What will be the answer? You will say, sir, it's better to go that only one thread at a time should execute this particular scenario. So that is the reason. This is what we are doing in the concept of your synchronization, so that whenever you are getting those resources, right, which can lead us inconsistency. It's not like that for all the resources हम सब resources के लिए synchronization method use करते हैं. No, because आप लोगों को drawback पता है. You know the drawback. Using synchronization हम concurrent execution नहीं कर रहे हैं because we are executing one thread at a time. But our major concern is related to inconsistency, right? So whenever you are getting only those resources, right, like related to book seat, but that particular, whenever we want to seat availability, seat availability, whenever we just want to check that is not our concern, let's assume. So for that particular scenario, we are not going to use the concept of synchronization. But for booking a seat, we are going to use the concept of what your synchronization, so that only one user can basically book that particular seat. Okay. So this is what we call it as what your known as your synchronization. So I hope that you know the concept of synchronization. Is there anyone who is having any doubt with respect to the meaning of synchronization? He or she can directly ask me if anyone is having any doubt. Okay. So what if we are just directly executing this particular thing now, so it leads to race condition. Race condition means if our user 1 is executing first, user 2 is execute, means order of your execution will change. So in reality, what we are doing, whenever we are executing our thread, we are getting different output, right? So this is known as what your race condition. So whenever we are executing our program, we are getting different output, right? So this is known as your race condition. So this thing we are able to solve using your synchronization, but our major concern is related to consistency. We always want that we should always get your consistent data, right? Now, how can we achieve your consistency? So is it any way in Java programming language through which basically we can achieve your synchronization in Java programming language? So yes, there are 4 ways. First one is we have to use this keyword named as your synchronized keyword, right? So in non-access modifier, I have already told you about this particular keyword, right? That is your synchronized. And this is a non-access modifier like our final, static, right? Volatile, native, right? Like that. So where we can basically apply this synchronized keyword with your instance method, with your static method, with your code blocks. Okay, so I will tell you what do you mean by code blocks using some examples. Right now this. So how to create, this is just an syntax. So whenever you want to make some method, okay, which method, where you are feeling like, okay, if if multiple threads will execute that particular method, now let's assume book method. So what I will do, I will make this particular book method as synchronized method. Now, whenever I am going to write now, this method will, whenever I am going to make this method as synchronized method now, then only one method, remember, only one thread at a time can execute this method. I will tell you a few examples, and through those examples, I am 100% sure that you will understand that particular this topic, right? So you can apply basically this synchronization in your methods as well as in your instance method as well as in your static methods, right? So actually what we are doing in the case of synchronization now, so whenever you are using this synchronization keyword with respect to any method, then basically if any thread is executing this particular method now, then automatically what it will do, it will lock. Remember, ye kya kar dega, it will lock this particular method, and it will lock when what till it will execute this entire method. Okay, jab tak ye puri method successfully complete nahi karta, then in that case tab tak kya karega, then it will lock. So that agar T2 method, suppose thread T2 wants to access this method, so what it will do, it will wait. Okay, what it will do, it will wait. So similarly in the case of book के केस में क्या है, let's assume हमारे पास 4 यूजर हैं, make it at T1, T2, T3 and T4. Now suppose 4 users wants to execute and book that particular seat, but you remember that at a time only one can book. So that is why once, let's assume T1 gets the chance now, so what it will do, it will log this particular method, so that whenever T2, T3, T4 wants to access it, so they can't, because T1 has already logged this particular method. So whenever you want that you have some critical section, we generally call this as critical section code, critical code, which you don't want to basically, which might lead us, which might give us some inconsistent result. Okay, if we are basically executing that particular section concurrently. So that is why for that particular scenario, always try to make that particular method as your synchronized method, right? So how can you make methods as your synchronized method? So if you will check it out, see, in the first case, I have made our method, this method as what my synchronized method. So what I have to do, I have to just write it down, this keyword, right? So you already know कि हम कैसे keyword use करते हैं. Similarly, we have one keyword named as your synchronized keyword. And if you want to create synchronized block, so this is how basically you can create synchronized block. You have to write synchronized, then you have to write this. This means you are passing some objects. Okay. So if you want to lock some objects, so you can lock only two things. Either you can lock objects or you can lock class, right? Like this. I will give you a few examples, and using those examples you will understand. So in our this case, we are locking what? We are synchronizing what? Our methods of, see, this is an instance method na? So you already know that, okay, we can call this method using what? Your objects, right? By calling an object na, only you can basically call this particular method, right? So this is how basically you are basically locking a object. You are locking an object. And for this particular scenario, you are locking a class. Now, how you are locking a class? See here, what kind of method I am creating? Static method. So it means here I am locking my entire class. Here I am locking only that particular object. Okay. So if I am creating that particular object, so I am locking only that particular. So if you want to lock this particular class using this synchronized block, so you have to write it down, this thing, demo class dot class. So you have to write down the name of this particular class. And if you want to lock this particular, what we call it as your object, then you have to pass this keyword. So this is a keyword we generally refer for your present object, current object, right? Now let's take this example, and I'm 100% sure that using this example, you will understand the concept of synchronization. Now in this example, what we have done is we have a class. Okay, so let's go for this. First go for our this particular class. This is our main class. In this class, what we have done, we have created an object of your table class. This is what my table class. See, this is what my table class looks like. Now, after that, what I have done, I have also created two threads. So right now, I think you already know कि हम threads कैसे create कर रहे हैं, right? Now I have created two thread classes. I have created differently, हाँ, दोनों आपकी thread classes है. In that thread class, you can see हमारा जो public void run method है, in that particular method, what we are doing, we are calling this method. We are writing t dot print table, and here we are passing an argument 5 because this is an argumented method, and here we are passing what? Your 10. Okay, sorry, 100, right? Like this. Now if we are going to execute this code, see, this code is not synchronized. Remember, this code is not synchronized because I am not using any synchronized keyword. So if I'm going to execute this code now, so I will get any output, any random output. You already know if I'm going to execute, so it might be possible I might get 500, 100, 200, 300, something like that, or I might get 500, something like that. So it depends upon our what scheduler. Okay, it depends upon our scheduler, what output we will get. Now let's solve this particular case with using synchronized method. Now what I have done, I have made this method as what? My synchronized method. Now what will happen in the case of synchronized method, I am telling you. So I am going to create, I have created an object named as what? Your, this is my object, that is my obj object, right? And this object are basically accessing by how many threads? T1 thread and T2 thread. And in this in this object, we have a method. We are calling a method named as your print table method. Which method? Print table method. Now what will happen? See, whenever we are going to execute this code, so you already know that our thread scheduler will tell us, okay, which thread will execute first. So let's assume our thread 1 will execute first. Okay, our thread 1 start executing first. So once our thread executing first, so it will go directly here and it will execute tprint and it will execute this particular thing. Okay. So once it will execute this particular method now, so what my T1 will do? It will log. It will log this particular method. Now, if T2 wants to execute this method now, so T2 won't be able to execute this method. So every time scheduler will check, hey, T2, do you want to execute any statement? So T2 will say, hey, I am not able to execute this statement because T2 basically has created some sort of lock on this particular method. So I cannot basically use this particular resource. Now I will use resource only whenever our T2 will start complete its execution. Okay, so T2 has already logged this particular object. Remember, because here we are using instance method, right? So it has logged your object. So T2 cannot perform on the same object. Remember, but if we are having some different object now, so it can work. They can work means concurrently. But for the same object, we cannot do that particular operation. Remember this point. This is very important point. So that is why if you will see, if you will check it out, the output of this one is what? First, it is executing our thread one T1 first, thread one first, and it is passing 5 now. So 5, 10, 15, 20, 25 we are getting. Then after completion of our thread 1 to T1, then only thread 2 will be able to execute it. Otherwise, what will happen? We will get the output like this, 500, like this is some like these such kind of output. So if you want to make, so here I have just given you one example, but where to apply? It's not like that you can apply anywhere this synchronized keyword. Please apply this particular, like for our railway. Suppose in railway what we have suppose get availability method. Remember, okay, suppose you are creating some method na, railway management system, suppose you are developing and you have book seat. So please don't make this get availability as a synchronized method, because see, anyone can access, because we are just reading it. We are just reading it, and there will be no inconsistency whenever you are just reading your data. The problem will occur only whenever you are writing or updating something. So where we are updating or writing something in our book seat method. So make this method as our synchronized method so that we will not get any sort of inconsistency, right? Like this. Okay. So what I mean to say is that as I can show you, suppose we have a class, okay, and in our class we have method m1, method m2, method m3, like that. Okay, and suppose I am having a class which is having, and we are creating an object obj of this class. Okay, I'm creating an object of this class, and this class and suppose we have thread t1, t2, t3. Okay, and suppose if we are not using basically synchronized, then what will happen? T1 will able to execute M1, T2 will also be able to execute M1 simultaneously. So concurrently, all these threads will able to execute these methods M1, M2 as well as M3 simultaneously. But if I'm going to make this method synchronized, remember, then if I'm going to write now T1 dot M1, suppose, then what will happen? Only then what will happen? I have made a lock on this particular method, in this particular object, not on method, but in this particular object obj. Then let's assume if T2 wants to access M1, remember, it will wait. It will wait till M1 will execute. But if T2 wants to execute M2 or M3, so it can execute. Why it can execute? Because these methods are your, you can call it as non-critical section method, or generally we can call it as your asynchronous methods. Okay, means their nodes are, so we can basically run those methods concurrently. So we can call, we cannot run only those methods which are synchronous only, right? So we can execute M2 and M3. Now let's take one more case. If I will make this method as M2 as synchronous, then what will happen? Then remember, then T2, if from T1 is, if T1 is executing right now M1 method, na, and so it has made a lock on your OBJ. So remember, T2 will never able to execute M2 method, because M2 method is again a synchronous method, and for synchronous method, our T1 thread has already made a lock. Okay, so we are not actually making a lock on your method. We are making a lock on either your objects, or either we are making on your, what we call it as your classes, right? So whatever the methods that are basically synchronous, na, so we are not able to access those basically methods. Only that particular thread who had made a lock, only that method can basically access that particular. Got the point? So if anyone is having any doubt, please feel free to ask. And if you don't have any doubt, that's great. But if you have any doubt, you can ask, right? Now.
Can you just share these PPTs to us in the LMS?
Yeah, I will also share this PPT.
Okay.
Okay, just after this lecture, I will share these PPTs,
Okay.
right? Yeah. Now, after that, what we have synchronized block in Java, right? So in synchronized block in Java, as I told you, so right now we are just creating what? These synchronized instance method or static method. Okay, similarly, you can use it for static method. But for static method, suppose if let's assume these methods are your static method, na? Our M1 static hai, suppose static, M2 static, and suppose ये आपकी synchronized है, then our T1 thread is not making a lock on OBJ, then it is making a lock on this particular class. Suppose ये class ABC है ना, so it will make a class on entire class ABC. Okay, so whatever that those static methods or that are basically synchronous, okay, having a synchronous keyword, we are other threads won't be able to execute those methods, right? Like that. So this is the syntax of your synchronized block. So see, what are the advantage of synchronized block? Now the question that comes into your mind is, sir, why we are creating a synchronized block, right? If we can basically make some method as your synchronized method, then what is the need of your synchronized block? Actually, what happens, suppose I am having some method void m method, and in this method, let's assume I am having S1, S2, S3, S4, S5, S6, or you can call it as suppose S100. 100 statements I am having, right? And out of these 100 statements, let's assume S99 and S100 might give us some sort of inconsistency. So what we want, we don't want to make this entire method synchronous, right? We just want to make these two statements synchronous, right? We want that, okay, all these statements can be executed by all these threads concurrently. They can execute all these statements concurrently, but not these two statements. So for this particular scenario, what we will do, we will create a synchronous block. Now you can see, we are just directly focusing upon these two statements. So if you will find out the throughput, so our throughput or our time, okay, our execution means the way basically we are executing our code, it will get increased. It gets increased. Okay, it will get means we are going to basically increase our time. Sorry, decrease our time. Why we are going to decrease our time? Because see, because now all these statements are basically executing what concurrently. But what if I am going to, if I will make this entire method synchronous, then our T2 and T3 won't be able to access these statements also, S1, S2, S3 like that. So it will wait. These methods will wait till whenever this entire T1 will execute this particular method. Then T2 will execute this method. Then T3 will execute this method. Like that. So it will take a lot of time. So in order to sort out this issue, what they have done, they have made this block so that till this moment of time, all the thread can execute this statements. Now it will wait for only, so these two, T2 and T3 will wait only for this particular block of code. And after that, once it will get executed, T1 will execute, then T2 will get a chance, then after T3 will get a chance. So that here again we are not getting any inconsistency, or we are able to execute our code. So here in this case, you can see over there we have created a block, and whenever we are writing this now, means this is referring our current object, right? This is referring our current object. So here we are writing, here we are creating this particular object, see, like this. So basically we are referring our current object for this particular scenario. Now one more question. I think none of you have asked me this particular question, but that question you must have in your mind is that the concept of deadlock. What do you mean by deadlock? I am telling you. Suppose you have a thread T1, you have a thread T2, right? We have two synchronous method. So I am just writing S means synchronous, okay? Synchronous M1 method. Make it as, suppose here. It's better to write it here. Okay, so yeah, here I will explain. We have a program, suppose class ABC having void M1. I'm not writing the entire statement, okay? Suppose we have some statement, void M2, void M3, void M4, like this, okay? So it's better to explain it here. So suppose we have a thread T1 and T2, and suppose what will happen, suppose our thread 1, see our thread 1, this is our thread 1 T1, this is my thread T2, this is my M1 method, and this is my M2 method. Now thread 1 is executing my M1 method, right? Thread 1 is executing M1 method, and M1, remember, M1 method is our synchronous method, right? Which kind of method? Synchronous method. It means T2 cannot execute this method. And let's assume T2 got start executing M2 method, and M2 method is what, again, some sort of your asynchronous method, something like that, okay? Now what will happen in this particular scenario is that it's better, I think I have made this particular example complicated, okay? So it's better to make it quite simple so that you will understand the concept of this deadlock. It's better I should go for this particular case, right? Like this. Class your XYZ. Okay, so I am having ABC class and XYZ class. Now let's assume I am having one thread T1, and all these methods are synchronous, huh? All these methods are synchronous. So suppose T1 start executing your M1 method, right? So you already know that T2, our T2 cannot execute, right? T2 cannot execute our M1 method. Can T2 execute M1 method? No. T2 cannot execute M1 as well as M2 method, because here we have made a lock on that particular object. Now what T2 will do, let's assume T2 is start executing our, so there might be some scenario, not every time we will get the deadlock, okay? There might be some scenario. Suppose T2 start executing XYZ problem class, and in this class what T2 is doing, T2 is started executing M3, right? Like this. Now let's take inside this M1 method, now T1 wants the resources of your this M3 method, okay? M1, we required the resources of M3 method, and in M3 method we required the resources of your M1 method. So can we call M1 method from this particular method? No, we cannot. Why? Because T1 ने आपका lock लगा रखा है. Can M1 method call this M3 method directly? No, M1 method cannot call directly because T2 ने lock लगा है. So basically, if you will find out, both the threads have made a lock on their respective methods, and they want to call other methods too in order to complete the execution of their methods. So अब ये दोनों के दोनों क्या हो पाएगा? Then in that particular scenario, none of these methods will able to execute. Why? Because they are waiting. Both these methods are waiting whether T2 will release the lock or T1 will release the lock. So they will keeps on waiting and waiting. Who will release the lock? Who will release the lock? So we will get nothing. So we will get nothing in the output. It will keeps on waiting and waiting. So if you will basically execute these such kind of code, so after some statement you will get this. It will means you will get the runtime window, but it will keeps on checking the thing that whether anyone. So you can call it as like your system get hanged. Okay. So whenever our system get hanged, so what will happen generally in most of scenario, we got some sort of deadlock. Okay, just because of deadlock we get our system what you're hanged, right? So similarly here, both the methods will keeps on waiting and waiting and waiting, and then in that scenario at the end, what will happen? Nothing will happen. Then we have to basically terminate. Either we have to close the particular program, or we have to basically exit this particular program, something like that, because we will not get an issue. So this is the issue. This issue might occur due to synchronization because we are locking our system, right? So this is known as your synchronization. Sometimes two or more thread needs to acquire the lock on several shared threads, right? This kind of could cause your deadlock in which each thread has the lock on each of the object and is waiting for the lock of other object. So by the way means it means that both or the locks, both the threads are waiting for each other. Who will unlock first? But nobody can. Okay, so this is just an example of deadlock and how we will prevent it. While prevention is not that much easy, okay, it's not like that we will be able to prevent it if we are getting, if we will get struck it. Okay, so I either restart again or what we generally do. So there are few techniques. What we have is we can assign the order, okay, on the object. We can assign the numbers. Okay, while it is not that much applicable, I must say that we never use this approach, but it's better that whenever we are implementing any code now, always try to remember that we will never get these such kind of scenarios. Okay, so if we are getting it, so then we have some deadlock mechanism. So in deadlock mechanism you are going to learn in your operating system. Okay, so I don't want to cover it here, right? So this is all about our multi-threading. So now we have completed the entire concept of multi-threading in Java, right? So now if anyone is having any doubt related to that, please feel free to ask.